Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of methylenic, CH2, hydrogens depends on the stability of the carbanion formed after deprotonation. Greater stabilization of the conjugate base, carbanion, through resonance and inductive effects leads to higher acidity. Moving on to the next step. Identify the methylenic, CH2, group in each compound and the electron withdrawing groups, EWGs, flanking it. A. CH3 CH to CH3, the CH2 is flanked by one ketone carbonyl, C is equal to O, on one side and a methyl group on the other. Only one EWG stabilize the carbanion. B. CH3 CH to to H5, the CH2 is adjacent to one ester group on one side and an ethyl group on the other. Only one EWG, ester, stabilize the carbanion. C. CH3 CH to CH, to H5, 2. The CH is flanked by two ester groups, malonic ester derivative. Two ester EWGs stabilize the carbanion via resonance, but esters are weaker EWGs than ketones or nitriles. D. CH3 CH to CN, the CH2 is flanked by a ketone carbonyl, C is equal to O, on one side and a nitrile group, CN, on the other. Both are strong EWGs that stabilize the carbanion through resonance and inductive effects. Moving on to the next step. Compare stabilization. A nitrile group, CN, is a stronger electron withdrawing group than an ester because it withdraws electrons both inductively and through resonance. Pi system overlap with the carbanion lone pair. A ketone carbonyl is also a strong EWG stabilizing the carbanion by resonance. Having both a ketone and a nitrile flanking the CH2, as in option D, provides the maximum cumulative stabilization of the resulting carbanion. Option C has two ester groups, but esters are less effective at stabilizing a carbanion compared to the ketone plus nitrile combination in D. Options A and B each have only one EWG adjacent to the methylenic carbon. And for the final step, rank acidity. The order of acidity D, C, A, B, because CH3 CH to CN has two strong EWGs, ketone plus nitrile, giving maximum carbanion stabilization. Why other options fail? A. Only one EWG, ketone, less stabilization than D. B. Only one EWG, ester, which is weaker than a ketone, least acidic. C. Two EWGs but both are esters, which are weaker than the ketone plus nitrile combination in D. Therefore, the correct answer is D. Therefore, the correct answer is option D.